So my name is Carl Carlson, and very happy to be here, talk about a subject about which I feel a great deal of passion. It has to do with creating effective reliability plans. This is the second in a two-part series on reliability planning. The first one was a little over a week ago where we talked about selecting the right reliability tools, and this one builds on it. If you haven't heard the first one, that's fine. We will briefly review where we got to, and then that first one is available for you to listen to. And so you can fill in the gaps from that viewpoint. So please stick around if you haven't been to the first one. And if you have been to the first one, then this will build on it and you'll see how that works. Just a word about myself, because I can tell you my background as to what I'm bringing to the webinar. I've had 35 years of experience, a lot of it in reliability engineering, and I'm going to say most of it at this point in management of reliability projects. The last 15 years, I've been teaching and consulting, FMEA and reliability management. I've been working with over 100 companies and have spent a number of that amount of time with ReliaSoft clients, but also other clients from a wide variety of industries. So I intend to bring in that experience to the subject of reliability planning. And if I could say a word, experience, according to Oscar Wilde, the Irish poet, experience is the name people give to their mistakes. So I plan to share with you some of my, let's call them lessons learned, because we all learn from each other. And I want to share with you some of those lessons learned on how to make good reliability plans and how to, because a good reliability plan will get you to where you need to be from a reliability standpoint. There'll be plenty of time to ask questions and provide comments. Use the chat window if you have a question at any time, and we'll take it up. Fred will interrupt at the right timing. So let's begin. The overview of the webinar, we'll talk about what a reliability plan is. Just a few slides that are similar to what we showed last week, but just to bring everybody to the same point. Then we're going to talk about the philosophy. I always think it's important to share the underlying philosophy that drives the subject, in this case, reliability planning. We'll review the primary steps to achieving high reliability, and then which ones we'll cover today. Then the webinar is creating effective reliability plans, and then I'll share with you at the end how to avoid some of the common pitfalls. So what is a reliability plan? Oh, one of my favorite quotes. Philip Crosby was a leader in quality methods and originator of the term zero defects. He said, good things only happen when planned, bad things happen on their own. So let's make good things happen with reliability planning. Starting with the definition of reliability, and I think it's always important when we talk about reliability to start with the definition, because some people think about reliability as primarily a probability or some type of metric. But Fred and I teach and have written for years that we want to include all of these four aspects whenever we talk about reliability. Yes, there's a statistical measure like probability, but also there's an intended function that's associated with that statistical measure. There's always a designated time period, and it's important that we talk about the specified operating and environmental conditions. When I started out with GM many years ago, General Motors, I used to be manager of product reliability there for a number of years. Reliability was specified with a number and a time frame, but it was not hardwired to the intended function and the operating conditions. So when I took over their product reliability group, one of the things I did is I said, let's get reliability requirements properly defined, because that's the beginning of a reliability plan, is starting with those type of good requirements. So next slide is, let's talk about the definition of plan. And the essence of this definition that I want to bring to you. Yes, of course, a plan is an intended future course of action. You're going to achieve certain goals and objectives. But the important part of this is it explains in detail what needs to be done, when, how, and by whom. So in pulling it together, the definition of reliability plan is the entire set of tasks that need to be accomplished, including responsibility for execution, the timing, and importantly, the resources to achieve reliability objectives. So that's going to be a theme throughout this webinar, is doing reliability planning in the right level of detail, not too much detail, not too little detail, so that we can get the objectives met. The objective is to design and manufacture a highly reliable product on time and in a cost-effective manner. And if you're in the operations and maintenance side, after the product development process, it's a similar objective, but it's to ensure that the operation of equipment is reliable and safe. Now, what is a reliability plan not? It's not merely a list of reliability tasks. I've seen all 5 of these bullets. I've seen lots of reliability plans that do just one of these bullets. I've seen a list of reliability tasks. That's not a reliability plan. That's a list of reliability tasks. I've seen it as primarily a test plan or a reliability test plan. That may be part of a reliability plan, but it certainly isn't the entire plan. I've seen people take a copy of MIL Standard 785, which is the MIL standard on reliability plans, and basically create that as like a template. I've seen a statement of intent to achieve reliability goals. In other words, the plan is a bunch of, we're going to do this, we're going to do that on reliability. And I've also seen general words and verbiage about how plans will be achieved, that type of thing. So that's not what we mean by reliability plan. Yes, some of those things can be incorporated into the plan, but it's more than that. Next slide. A word about management, because as we talk through this webinar, I want to emphasize the importance of coordinating and getting management involved right from the beginning on reliability planning. And this is a quote from, it's written by John Braden, who's a reliability consultant and published through a really good book on reliability engineering and management by Ireson and Combs. Management's attitude toward reliability expressed through policy is the most important single ingredient. He talks about that, and that's so important, that the attitude towards reliability. We want a commitment, not just a cheerleader, not just a, go forward and do it type of thing, but involvement all the way through. I remember Winston Churchill said, attitude is a little thing that makes a big difference. And it makes a big difference in reliability management. So now we're going to shift to the underlying philosophy. Remember I said that it's very important to define and share your philosophy. I would encourage you throughout your reliability career to always begin conversations with your colleagues and management from your point of view, your philosophical point of view, because that's what resonates with people. So let's share some of those points. Another quote, intellectuals solve problems, geniuses prevent them. Albert Einstein was spot on there. It is true, and it takes good engineering talent. I don't mean to demean solving problems, but you cannot achieve high reliability in the very competitive environment we have today. Fast to market, cost pressures. You cannot achieve high reliability by purely solving problems. You have to prevent them. That's what Design for Reliability is about. So just a few slides on the philosophical approach. We'll want to use a systems engineering approach, and basically reliability is one of the ILIDs, one of the systems engineering disciplines that come together. You're a team member in reliability working with other disciplines like product engineering, manufacturing engineering, maintenance, service, all those areas and many more we design for as we're going through concurrent product development. And systems engineering brings it together. So you want to be a good player as part of the team. And of course, if you've seen the V chart, which is what this is called, you start with conditions of use, operating profiles, and then you work through system requirements, subsystem, component. So we're basically flowing requirements down. And then a big part of that V chart is designed for reliability and manufacturing. And then, of course, you're going to assure that you've met the requirements, starting with components up to subsystem systems and then the okay to launch. And in that, you're getting all the integration areas and the interfaces. And so that's a systems engineering approach. It's a good philosophical base. Another philosophical base is moving from design as test and fix. You design the part some way, like the way you've always designed it, and then the company does test and fix. I call it the test and fix treadmill. And we've been shifting from test and fix to design it in for at least a couple of decades. I remember the first paper I wrote was in 1994, and this particular visual is from that 1994 paper. And we're getting very close to this now. Fred, I know Fred will remember this, and some of you might. But if you're newer, you might not know the history of this. We did not always have design for reliability. Testing used to be the primary focus of reliability engineering back in the 80s and the early 90s. So it's been a long journey, and I encourage you to make this part of your philosophical base, that we want to design reliability in as well as design in the other disciplines. The next slide I want to show you is what I call the reliability equation. This was actually developed by a colleague of mine at General Motors. He headed up the robust design group. We brought in people from all over the country, PhDs and masters in reliability and statistics, and developed robust design approaches. And the focus, let me back up. Reliability is a function of certain parameters and stresses and environments and materials and usage. A lot of the focus early on was measuring reliability, and that's still important. But equally important, and I think even more important, is managing the process inputs. Because if you can manage the process inputs, first of all, defining them and then managing them, then you'll achieve reliability, and the measurement's going to be where you want it to be. If you focus on the left side of the equation primarily, it's going to be a long, long haul to achieve reliability objectives. So the answer to this, where should the emphasis be, is the right side of the equation, identifying, defining the right stresses, parameters, environments, so that you achieve reliability. And the reliability engineering talent is understanding that transfer function so that we can get our objectives met. So that's an underlying philosophy to a reliability plan. Next slide is, and think of some examples of this as I'm talking about it, but designing for reliability is an important part of the philosophy. You could design out failure mechanisms. Not easy to do, but you can do it, and you should first try to do it. You can reduce variation on the product strength. Remember those strength stress curves. You can see those on any reliability statistics class or software. They'll show you the stress strength curve. So you can reduce the strength variation, or you could reduce the effect of usage and environment. And of course, you can increase design margins by separating stress strength. Those are different strategies. Those are not the only strategies, but those are some of them. And I encourage you to think about those strategies as you're developing your reliability strategies and your reliability plans. DFR requires knowledge of product and processes and understanding of failure mechanisms. If you can understand failure mechanisms, you're more likely to be able to manage them well so they don't happen. Your failures don't happen within the product life. So that design for reliability is a big part of the strategies. Summarizing, And before I don't want to just read off the bullets, but I'll state that this is so important that Fred and I have made the underlying philosophy for reliability planning as chapter 2 of our book. And we'll cover a number of topics on good philosophy that drives excellent reliability plans, such as organization-wide effort, management-driven, focus on prevention, selection of the right reliability tasks, and executed through a comprehensive reliability plan. That summarizes the philosophy part. And then let me get to what we'll call the first of a couple of quizzes. So this is interactive. I appreciate if everybody could participate and choose as many as you like. It could be 1, 2, 3, 4, 5, all of them, or any one of them, or none of them. But select the answers here that you think are true regarding reliability plans. Number 1, they're developed and approved by reliability engineer. 2, driven from bottom up. That means from the engineers up to management. 3, are written after reliability gap analysis is completed. Now, we'll explain that if you're new to this webinar, but if you saw the last webinar, you know what that one means. You start with a gap analysis. 4, should focus on fixing problems. 5, incorporate design for reliability methods. So take a minute and just click on the which of those you think are essentially true regarding reliability plans. And we'll give a few minutes for that. And Fred, when you think we've had
it's slowing down. Looks
enough
like
of the poll, let me know.
You kind of stressed it
And
the
maybe you
last
can
couple of
summarize,
slides
Fred.
on the DFR method, so I think people picked up on that. But if I had to answer this, and I should probably click on it myself, I'd say the DFR stuff and the gap analysis, kind of the heart of what we talked about, or what you talked about last time. The other ones, I'm not so sure about. I think there's partials in some.
Okay, very good. And I tend to agree with you, Fred. So if you want to shift it back to the presentation mode, let me just share with you my thoughts. And I know some of you put down the first one because, and I understand that because maybe the reliability engineer begins the process, but I want it developed and approved as a team, not just by the reliability engineer. So you're going to see that in the rest of this webinar, that we want the reliability plan to be developed by a team of people, including management, not just by the reliability engineer. And of course, it should be top down, and the gap analysis is a key input. And we don't want to focus on fixing problems. We want to focus on preventing problems, and then we incorporate design for reliability. Doesn't mean you don't fix problems. Of course you do. But we want to focus on prevention. Okay, so then continuing on, this is the primary steps to achieving high reliability. We introduced this in our introductory chapter in our book, and then in the book that we're going to be publishing, each of these 5 steps has a chapter that gives examples, lots of details, lots of how you do it, and aligns it to different scenarios. In the first webinar, we did steps 1, 2, and 3. In this webinar, we'll talk about steps 4 and 5. So that's why it's a 2-part webinar series. And I'll explain, I'll do one slide on steps 1, 2, and 3 as a review, and then we'll go into detail on steps 4 and 5. So let's begin that. So a refresh for those that were here the first one, and only one slide on this, is the reliability strategic vision. This is beginning with the end in mind, to use a Stephen Covey phrase. It's the envisioned future from a reliability standpoint. But I don't just mean the numbers. We want to talk about the infrastructure, the resources, the skills, the methods capability. Where do we want to be in 1, 2, 3, 5 years from a reliability point of view? Developed with support of management, understood and agreed upon by all employees. So we have a strategic vision for where we're going from a reliability standpoint. So that's and to share the same quote from last week from the American baseball legend Yogi Berra, if you don't know where you're going, you'll end up someplace else. So let the reliability strategic vision says, here's where we're going. Then step 2 is the gap assessment. This is an important step. When Fred and I do reliability consulting, we always do a gap assessment when we're developing into a major program or a major project for reliability. You want to know where people are. Of course, you start with the strategic vision, but we're going to analyze the shortcomings, which I'll call gaps, to achieving the vision. This identifies the capability of current products and processes and the effectiveness or gaps to effectiveness of current reliability methods. Of course, we'll also surface high-risk areas. We do this by communicating and interviewing and talking with individuals and teams on site. And you can do this inside your company. When I was a manager of product reliability at General Motors, when we had a new Corvette or a new Malibu or whatever the program was, programs took a look at the gaps first. The gaps in reliability, the gaps in methods, as well as where do we want to be. And I would work with the chief engineers to see where do they want to be from a reliability standpoint. And those were 2 key inputs to the reliability plan. Okay, the third is selecting the right reliability tools. So you take the reliability strategic vision and you set reliability objectives. Now we're talking about the 4 elements of reliability: the probability, the intended function, the time frame, and the conditions of use and operating environment frames. Then we also summarize the gap assessment so that the right tools can be selected that close the gaps. And we want to use the Pareto principle. Remember, we talked last webinar about Dr. Joseph Juran, who taught the Pareto principle. We sometimes call it the 80-20 rule. We want to identify the vital few tasks. We don't want to just list every task known to man and beast on reliability. There's dozens and dozens. I think there's upwards of 70 or 80 if you count any type of tool. We want to get the vital few because that's what's going to get traction in an organization. So that's a review of how we got to this, where we are in the webinar today. Step 4 is creating effective reliability plans. So we're going to talk about this in the next few slides. This is where we establish the strategy and the actions that will achieve reliability strategic vision. We develop the specific tasks that close the gaps. Now, by tasks, I'm talking about the who, what, when, where, how, specificity. We're going to transition from the list of reliability tools like FMEA to what tasks are going to implement FMEAs. We pull together all the necessary resources, address the high-risk areas, and strengthen organizational shortfalls. So that's creating an effective reliability plan, and we want specificity. Next slide is, I'll have 2 slides here just showing kind of an overview. I asked myself, and Fred and I have talked about this, how do you create effective reliability plans? So a very high-level overview. You want to gather the inputs. So we're going to get that strategic vision, the gap assessment summarized. And if you haven't seen that, please look at the first webinar because it gives example of what we mean by strategic vision and gap assessment. And then the list of selected reliability tools. So that's input. Then, of course, you have to know your scope. Are you talking about a program, which means company-wide, overall, or a project like the Malibu or Corvette?
Hey,
We also have to
Carl,
decide the scope. Are we focusing on design, manufacturing,
on the
service,
gaps on those
field?
first two parts,
What's
and I
the
don't know
scope
that
of
you
the
covered it
plan?
in last
I
week's one,
typically like to
is
include all of
in the
those
gathering information,
because
where
they're
would you
all
include the
important in
customer's
achieving customer
expectations
satisfaction.
and the
But you have to make
competitors'
that decision.
type
And then
inputs?
the next slide, go ahead. Sure. Excellent. Excellent. So in establishing reliability requirements, and we'll talk about this in our book, uh, it's very important that you understand customer expectations, benchmarking where the competition is, because we want the reliability requirements to meet customer expectations. We want them to be able to achieve our objectives regarding competitors. Some of you will be familiar with a tool which is not the subject of this webinar, so I won't go into detail, but quality function deployment, or the house of quality, where we start with voice of customer, is one of the ways to develop requirements. And so, yes, when we develop reliability strategic vision and the reliability requirements, we take into account customer expectations and benchmarking competitors. So, very good question, and I appreciate that. Let me go back then to the next step. Write the tasks at the correct level of detail. So now you've got everything, you got your ducks in a row, you've got good preparation. Now we can start writing tasks. So here's where we move from tools to tasks and what I'll call subtasks. We want to include both organizational and method tasks, put it all together into your plan, interact with management for approval and for execution. So that's at a very high level. So let me give some examples now. This is a table of contents, kind of an overview of a table of contents in 3 slides from a number of reliability plans that I've done with clients. I typically like to have a summary where I summarize the purpose and content of the plan. I always summarize or outline the overall vision for reliability. 1 paragraph or 2 paragraphs. Then I summarize, either right there at the beginning or as an appendix, a summary of the reliability gap analysis. And here's where all I want to do, and it was, you'll get examples of this in the first webinar, an excerpt here, but summarize the gaps between reliability strategic vision and your current reliability capability. And I've also stressed last week, don't forget about the strengths. So, because the strengths can be leveraged, and frankly, when you talk to a department or an organization or division, and you only talk about gaps, it can be a bit off-putting. And so I think it helps to say, you're doing this really well. Now here's some gaps. The 4th thing is the philosophy. I briefly state the philosophy, the underlying philosophy behind the reliability task selection. Let me say a word about that. We are always teaching. We are teachers as well as reliability practitioners. We are influencers because you do not, as a reliability engineer, achieve reliability on your own. You influence the organization to achieve reliability. And one of the ways you influence is talking in, I hope, a passionate voice about what you're trying to achieve. And summarizing the philosophy can be that passionate voice. Continuing on then, on the table of contents, the second of 3 slides. In this portion, I would say this is the bulk of the reliability plan, although you'll see there's more to it on the next slide. I like to align the specific tasks that must be done to close gaps and achieve the reliability strategic vision. I like to align those to the product development process. Now, A, B, C, D, E may or may not align to your product development process stage gates, but every company has a set of gates that they go through. Some, they call it different things, but things like concept or design or assurance or manufacturing or fields. Those are different stages. And I like to align the tasks to those because it communicates with the organization. This is part of the communication and the influencing of the organization, if we can do this. And then the another section of the reliability plan is the resources and training. We're outlining specific tasks that support resources and training, and then outline specific business process tasks. That's the organizational tasks that institutionalize reliability. Remember I said that the reliability plan should include the methods, how you're going to achieve your FMEAs, your HALTs, your design margin analyses, things like that, as well as your organization, who needs to be trained, who needs to be hired, what organizational guidelines need to be written. And then lastly, I like to include a tools reference section, an appendix that either links to references for the tools or includes references. So when you say you're going to do some study, like a finite element analysis, as part of your reliability plan, then you can reference how that's done. As you can see then, the reliability plan is got a breadth to it. It's got a number of sections to it. It's more than just a list of tools. Okay, so let me talk about tasks in the next 3 slides. And your tasks don't have to be this verbose. They can be less wordy, if you like. But I want to just share with you what I try to do in defining the tasks and the subtasks. So let's take an example. Let's say we have a gap or something important that we need to be done called a system reliability model. We're going to do system reliability analysis, and we'll use a model for that. And then, so in introducing that task in my reliability plan, I like to define it. What is it? Now, I also like to state the application information. Once again, if you've done a number of these and your team is well conversant with it, you may not need to do that. But remember, we're always teachers. And so I take the opportunity to say, we're going to do a system reliability model, and here's what it is, and here's how it's used. Then, I like to break it down into the action steps. The specific steps, called these subtasks, here's where we break it down into who's going to do what, by when, and how. So I have who's responsible, the dates, the resources. So for example, ensure at least one person is trained, determine the system configuration, develop the system reliability model, and use it to analyze subsystems. And then you could break that further down if you wish. Use the system reliability model to analyze and predict system reliability. And of course, you can update that with FMEA occurrence information if you like, or certainly update it with test data because it becomes more accurate as the product development process is underway. And then of course you can continue to update it, and each of these subtasks have who's going to do it, by when, and how, and you can reference a technical guideline if you have one. So that's an example of a task that supports the tool, the task and subtask that supports the tool. And I like a level of detail about that or less if you've got an organization that's well trained and well, if you can introduce it with less than that, that's fine. But get enough detail so it does get done. The analogy I'll give you is painting a house or painting a room. If you've ever painted a room, more than half the work is preparation steps. It's go out and buy or decide what color is the paint. Go out and buy the paint. Get it mixed, sand the wall, buy the right brush, get a ladder, paint the room,
Carl, we got a
let it
question
dry, etc. So
there was one that I was thinking
you wouldn't
too, and
want to
Gregory
just
put
state
it in good words.
paint
It
the
was,
room
did
as
we
your
adopt a
reliability or your
standard, or are we
paint
building
plan.
one ad hoc?
You would give those steps to have a good paint plan. So that's
And
the analogy I'll give.
My understanding, and from what we've talked about over the years,
Sure.
and is that the teaching part is taking that reliability standard that you may have in-house or you may have as a separate document. We used to call it at Hewlett Packard a design for reliability manual, basically, that we used internally. But the plan could reference that stuff. And if you don't have that, then the short paragraph of what this tool is and why we're using it is part of that teaching role. But it's not to use a standard carte blanche. You don't pick up a particular template or standard like you talked about earlier. So in effect, Gregory, I think we do create in the plan, we build off of standards, we build off of common terms and definitions like what an FMEA is or HALT is. And it's fitted together, though, to achieve the objectives within that particular situation. So in part, we're building a plan uniquely for each circumstance, building off the knowledge that we carry in the standards. Would that be a fair answer?
Yeah, very good, Fred. Yep, that's a good answer, and Gregory, very good question. Uh, Fred and I are both conversant with the standards that are published. The Bill Standard 785, the SAE JA 1000 and 1000-1. Those are standards, and there are others that relate to reliability. But we want to go beyond that because we want to tailor and make very specific the reliability plans to your company. And therefore, a standard might be a background knowledge, but frankly, don't think the published standards have the length and breadth of the subject. And I was involved on the SAE standard the team that authored that standard. So I'm very familiar with it. And I would say we don't have a standard that's published that is good enough just to operate from. I would say understand the standards, but also understand what Fred and I are teaching. Then I think you'll have it. Okay, so let me go on. And I appreciate you've got a PDF of a document that I would love to look at after the webinar. Thanks, Gregory. Continuing on, here's a second quiz. And I encourage you the way to do this is to use the chat window. And we'll take a couple minutes. And because obviously A is probably not the best way, unless you think it is, and then tell us why. But if you think B is better, in other words, we want to perform required FMEAs, but we're going to break it down into steps. Please just outline for us why you think the approach from B is a better way to develop your reliability plan than putting in the verbiage perform required FMEAs as the only verbiage you put in there about FMEAs. So just take a minute and type in some things. I encourage everybody to give it a try as to whether you think A is better or B is better and why. And Fred and I will be looking at them. And don't be afraid. When I teach on site with companies, I always say, part of learning is putting things into your own words. So we're not recording this in terms of for posterity for your answers. We're basically part of learning is to try to put things in your own words, and that's what I'm encouraging you to do here.
William,
so take a minute on this.
Note there, Carl. It's comprehensive. B is more comprehensive. Yet I've run into this where you get a management team that just gives me, make it short. I want a plan on one page kind of thing. So I think there's multiple audiences for these plans.
Yes, I totally agree. And then I think that's a very good comment. You can, I've worked with many management that wants to see only a one pager. Don't want to see any more detail. Fine. So for them, I would say we're going to
See Brian's
perform the
comment?
required
It's, I
FMEAs.
could ask him
And
to do
Mr.
the
Manager,
FMEA.
we will go
Now, this
into
is, I think there's
the
two
necessary detail to
aspects
get
that,
it done.
Brian, is one of
But
the
we're going to
plan is
perform.
in conjunction with
But
your
behind the
team,
scenes, I
so
would
that
want to
these are
have
the
the
tools to help
operating
them
targets,
achieve the
so I know
overall
specifically
objective
what is going
of
to
the
happen.
project you're working
And so
on.
people agree to
So
it.
it's your recommendations, not a ask, not a request. It's if you want to understand and prioritize the risks to the reliability performance of your product, then this design FMEA is an appropriate tool. So you're picking up the right tool out of the toolbox and saying this is how we solve that particular problem or need that the team has, and then connect it to why it's useful or valuable to them. And that often helps get past the idea of just listing it and then getting trying to get buy-in later. Is you really work to get that buy-in and understanding of why these tools are in the plan right from the start.
Excellent, excellent. Very, very good comments. Tim, I appreciate that. The test plan can be one of the outcomes of the FMEA, and so you could have that as part of your objective. Um, and the Thomas allowing the organization to better determine the resources, and Andrew's comments. So very good comments, and I appreciate that. Thank you so much. Let's continue on just from a time standpoint. So the next slide is really, I just want to give an example. We talked about aligning the reliability tasks in your plan to the product development process. So in the concept stage, you might have things like generate system reliability model, but remember to do the actual tasks and subtasks for these, or perform design margin analysis with the actual tasks and subtasks, etc. Develop accelerated life test methods, could be during assurance. So each of these stages of product development has different tools and corresponding tasks and subtasks that are defined in sufficient detail. So the detail is very tailorable to your company. Some companies want to see more detail, others less. What's going to work to get the job done is what's important. What is management's role? I was very fortunate in my career to have a number of sessions with Dr. Deming in person. When he came back from Japan in the late 1980s, he only wanted to talk with management because he was in his upper 80s, and then he worked in through his early 90s. And so we had management sessions with him, a lot of interaction. Here's a quote from him that I think says what a lot of what management's role is. Support of top management's not sufficient. Not enough top management commits for life to quality productivity. We don't want just them holding up the right hand and saying, I swear and agree to quality and reliability. They must know what it is that they're committed to. That is what they must do. These obligations cannot be delegated. And here's the key sentence: support is not enough, action is required. So I want management committed to action. The reliability is not something that's achieved by a reliability engineer. It's achieved by an entire organization. And this could be likened to an orchestra. So a reliability engineer might be part of the orchestra, but everybody coming together, the woodwinds and the brass sections and the percussion coming together to achieve reliability is the way it's done. Otherwise, you're pushing on a rope and you'll not really achieve what you can achieve from a coordinated effort. But it takes management to get that coordinated effort. So we have a few more slides, but be thinking about questions, because I'm going to save about 12 minutes here on this webinar for follow-up questions. So please be thinking about and start putting into the chat window questions you have, because we only have a few more slides left because we saved some time at the end. Step 5 is execution. We want to leverage management support to ensure each task is properly executed and all gaps are closed and reliability objectives are met. Execution is incredibly important. We used to, years ago in GM, we'd write what we're going to do in reliability. It was published as a memo, never arrived in the technical specifications. It basically ended up in someone's drawer, but it got checked off as a checkbox during project development. So that got changed, and now execution is a big part of it. So you may need to get your tasks integrated into other program documents so that the project teams and program teams can execute reliability tasks as well as executing other tasks. The key is developed with management support, the reliability plan, and approved. Assignment of person responsible is not just the reliability engineer. I don't want your name as the person responsible on every task. Like I said, it's an orchestra. So some of the tasks may go to product engineering, some of them to manufacturing engineering, others to test. So basically distribute the task appropriately to the person responsible. Write them in enough detail. Remember what, who, when, where, how, and then close out the tasks to close the gaps and achieve your objectives. One case study, I'll just take 1 minute on this. Walked into a company developing a certain type of unique transmissions systems. The company had no reliability plan, and yet it was 2 months to first prototype. I said, let me see your system requirements. They didn't have any, and their FMEAs were wrong. No design margin on critical subassembly. This is a true story. So, in other words, what they designed some critical parts to was the same stress that the parts were expected to see. So they didn't have a design margin. So I met with management to discuss shortcomings. We developed a reliability plan, including system requirements, proper system FMEAs, design margin analysis, and I learned that one of the first steps in reliability planning is good system requirements. So one case study there. And then 2 slides on lessons learned, and we'll do a wrap up. So please start thinking about your questions and write them down in the chat window. Lessons learned, understand the role of management. And I think we've summarized that pretty well in the webinar. Management needs to be involved throughout the development and implementation of the plan. Create a structured mechanism for execution. I like to write my plan tasks in an executable manner. And then you get the buy-in, not only of management, but of colleagues across the organization. I don't want you to do what I did in the past. Years ago, I wrote a reliability plan that handed out some tasks to other people without getting their buy-in ahead of time. I want them involved. Otherwise, you get the not invented here syndrome. Continuing on some lessons learned, clearly define roles and responsibilities. You can't be executed from bottom up on reliability. It's got to be supported top down. And I like to incorporate into employee job descriptions what their role is on reliability planning. Subject matter expertise is required. I encourage you to get trained, get your colleagues trained in reliability methods. You can't really, there's got to be some core. If you don't have a core that understands reliability, then you need to bring in people that do. You can't just muddle your way through reliability without understanding the principles involved. So very important. I think training is a lifelong endeavor. You never really achieve it fully. You're constantly being trained. Some of the state of the art is changing, technology is changing. And then lastly, I'll state the importance of people skills. Reliability is a team-based effort. You need to influence people. And so work on your people skills. Years ago, when I managed GM's reliability group, I would bring in outside consulting groups. We taught people some of the psychology skills, personality types, this type of thing, to give people some experience and some tools on the soft side of people skills that the universities don't train very well. Okay, so in summary, and we've got 10 minutes, so please think of some questions here. In summary, developing and executing an effective reliability plan is essential to achieving high reliability products and processes. So I always, on new programs projects where there's some new technology, new applications, new designs,
Yep, we
I
got a
want to
couple
get a
of
good
them.
reliability plan in
Ryan
there that's
was
based on
he sees
strategic
how.
objectives and gap
Oh, I'm
analysis,
sorry.
and it
By
has the
Bart.
tasks, the
Can
tools
you
selected, and the
speak?
tasks properly
The
defined.
chat window is moving too quick, so I'm
Okay,
having
so let's
trouble
open
reading.
it up. And Fred, did you get any questions in there that
The
you've been
role of
seeing?
design reviews. And
Okay.
I would add to that is, do we build that into the reliability plan or leverage existing review processes?
Yes. Ah, excellent. And remember we were talking about reliability as a part of systems engineering. In other words, it's part of the way you design and develop products. And the I led GM's team that developed the design review process. So on design reviews is really two types. One is a gate review that says, are you good enough to proceed to the next gate? The other is an ongoing set of more informal reviews with the design team. We call them board reviews, where you put up the drawings on the board or the wall, and you get feedback from subject matter experts. I like to see reliability integrated into the design review process. If you don't have a good design review process, then you could include it as a task
I'm going to jump to
in your
Tim's,
reliability plan.
ties
If
into
you
a lot of what you
have
talked
a good
about,
design
like
review
giving
process,
management support.
then you
He
can
says,
build on it.
how
Your
do you
task could be
deal with the
support
statement
the
of,
critical
if you
design
don't find
review or the different
errors,
stages
you either
with
didn't test
reliability
correct, or
input.
a product is too
So
good
that's my
and
thought.
hence too expensive.
Any other, what other questions do we have, Fred? Okay, if you don't find errors, in other words, let's say hypothetically you have a really, really robust design, and just out of serendipity, that was what was designed, and you're doing FMEAs, you're doing other techniques, and you don't find errors. That could be, it doesn't happen very often, because in most cases during product development, we do find design deficiencies, and HALT finds weaknesses, that type of thing. But it could happen. If it does, that's great, then we're confirming it.
so.
I also want to know what
I'm
the
gonna jump
design
over to
margin
Kevin's
is.
my
So
question
we
and
may
answer
say it's really
area.
good, but how
Now,
good
the
is it?
plan seemed to be
And what kind
focusing
of,
on
do we have
developing a new
sufficient
product,
margin
which is true.
in
I
terms
think
of the errors?
Kevin, both
And
Carl and I come from product development backgrounds.
I'm trying to see if I answered the rest of it. Fred, did I
The
answer that
task of
question?
improving reliability does exist on
Or do you have
existing plant
Okay.
equipment, so more from an asset management type of view. How would you vary these steps to accomplish working in a factory setting, for example, the factory equipment?
Excellent question. And as I mentioned at the beginning, these steps can be applied in the asset management, not during product development. I do a fair bit of consulting with oil and gas and other types of operations, nuclear, and where you have equipment that's in production, and the same techniques. You have a strategic vision. Where do you want to be from a safety and reliability standpoint in terms of operations? What are your gaps? How are you going to close those gaps? You'll just use different tools to close the gaps. There may be Fracas is a tool, obviously, that will help close the gaps. There are other tools that will close the gaps. So it's the same basic steps.
Output
The tool
as a feed
selection becomes
into
different
a
because
reliability and
you're on an
maintainability
ongoing
analysis
basis
model.
to improve safety and reliability, maintainability, availability, that type of thing of your equipment. Let's see what other questions we have, Fred. Yeah, well, couple comments on that. First of all, FMICA assumes we're going to do a criticality analysis, which is the additional step on top of the FMEA when it's called FMICA. And yes, FMICA is or FMEA or FMICA is an important input to reliability and maintainability analyses, and so I would integrate those together in the reliability plan. I like the reliability plan to be the length and breadth of all the different tools you're doing to achieve reliability and maintainability.
So there's
So
two
I
questions
definitely believe that it does
Chang
integrate.
and from Brian
It
that are
can be,
related.
you can have inputs to
Chang's
the
asking, what's
FMEA
the
such as
most
requirements,
effective way
and
to
the FMEA
sell?
can
I'm
clearly
gonna
be
put
an
air
input
quotes around
to
sell
some of
because
the
I
other
think that is the
reliability
right
tasks,
word.
such as Tim
Reliability
pointed out,
importance to
the
management.
reliability
And then
testing.
Brian has a similar,
Other
or
questions? We got about 5
in my
minutes.
mind, related question is how do you communicate the reliability plan's progress to your team and management? So a two-parter there for you, Carl.
Excellent, excellent. The reliability cell, and as I said, we're always teaching, we're always influencing. So I like to sit in with management on a regular basis. So not a one-time basis. I would like to be with them as we talk about the problems that are occurring or product development, this type of thing, so they know you as a reliability engineer or reliability manager. And yes, I like to influence them. And the way to do that, first of all, you need to be aware of the shortcomings, where the risk is from FMEAs, from other types of analyses, from field data analysis of similar parts. Where is the risk? Because the risk translates into money. And the way to influence management is speaking in the language of money. And the way to be credible is by talking about risk. This risk could cost us this amount. And you do that, and if you're credible and you're consistent, you will get management support. And then I just forgot the second part of that.
How is it going to influence our decisions? So it's the feedback is not just do a prediction and then update it as the bill of material updates. It's include the consequences of those various tasks, the prioritizing the risks, the
yes.
Choosing one vendor over another, weighing their reliability criteria. All of those elements in those discussions are part of the feedback, yet it's part of providing meaningful feedback so they can make good decisions.
Yes. Exactly. And for instance, going back about 20 years, I would be working with the chief engineer on Corvette, and I would be attending on a regular basis their project meetings, and I would let them know, here's the status of the FMEAs, here's the status of the reliability testing, here's the status of other reliability objectives, here's the risk that we're seeing, here's the unresolved issues, here's where we need your help. So it's an ongoing basis of updates so that they get a feedback loop and that reliability can continue to influence on an ongoing basis. That's also for asset management in operations, where here's where we are from a reliability and maintainability and operational basis.
Like selling quality.
And on an ongoing basis, here's the problems we're seeing and the risks. We got time for maybe one or two more questions.
It's very true. We got to communicate the value of what we did in order to build a credibility for the future, plus estimate the value for what's important to your organization. There was an earlier question about I've got a VP that I need their buy-in. Well, what's important to them? Is it customer satisfaction? Is it time to market? Is it low cost? What is it? Maybe the risk of shipping on time. If reliability can provide a tangible benefit for what's important to them, then you're talking in their language and they will associate that priority with what's important to them. So often a first trick is to understand what's critical to your audience and then match your sell to what's critical to them.
Excellent comments, Fred. And Fred and I will look over the
A good
chat
number of people
window,
are
and if you
chiming
had
in saying,
questions
"Good
or
job."
you're bringing up or
I
you
like the
continue to
one
bring
that
up,
was
we will be
very
sure
top
those
webinars
questions are
on
answered. We'll
reliability.
find a way to
Appreciate that.
publish those answers,
And Neil,
and
yeah,
so
good
that way we
prompt.
can
Let's
stay
round it
within
out
the
here,
1
Carl,
hour
with
time frame of the
slide
webinar,
on
but also get your
the
questions answered.
book we're working on, which is very, very similar to the last two webinars, and that's why we wanted to mention the book. And let me grab the link. We're putting the draft chapters up online on the Ascendo site. You need to be logged in to the site, become a member, which is free, and you can read the chapters as we post those in exchange for your comments and impressions and suggestions. And we posted the first chapter last week during the webinar, and we've gotten a bunch of really good comments so far, including typos and word choices and edits like that, which we certainly appreciate. Sometimes it feels like English is a second language for me. And writing is a process of editing as we go. And we've been getting some really good insights to areas that are a bit confusing, that aren't quite clear, and a handful of missing elements, topics that really should be in the book, and we didn't mention. So we're going to be following up with people to do that. You can find it at this website I posted just a moment ago, and log in, and you'll have access to it. You can leave comments directly on those pages, and we'll respond as quick as we can. And Carl and I are meeting pretty regularly now to discuss the comments and the feedback that we're getting and incorporate that into the work as we're going. And so we really, really appreciate that. And Carl, the recording for this webinar will be up on Ascendo underneath the podcast section, the reliability.fm segment under the Ascendo Reliability Webinar Series. And if you're logged in, you'll be able to see the recording video and the chat window and stuff like that there. So we can answer questions there as kind of a way to get the additional comments back out. And there's a handful of other things coming in, a lot of thanks and well done. Appreciate that. That's always a lot of fun. All right. So Carl, any last thoughts as we wrap this one up?
All right. I think that about sums it up. We've got a 2 webinar series. You're welcome to download them.
Right.
You're welcome to
Thanks,
listen to
everybody,
them again.
and we'll
And
have
it's a very
another
high
event this next
overview.
week, a
Lots
fundamentals
more will be in the
poll.
book.